Right, since number 3 goes from a constant to something other than just plain old x, we have 4x. It's more complicated than that. Things get a little bit more complicated. Complicate. So let's look back at what we have up here, and I'm actually going to, hopefully you have some room. I don't know if you guys wrote that down. But we're going to look at this when it's not just x. If we take the derivative with respect to x, the definite integral from c to u of f of t dt. So this u equals something in terms of x. Right, so it's an expression in terms of x. Could be 4x, like we have in number 3, or x squared minus 5x, or sine of 3x. Anything as long as it's something in terms of x. Well, we can still kind of use this shortcut, but we have to change it up a little bit. We have to add something. What happens is we're going to go ahead and take that u and put it in here. So we're going to get f of u, but the difference is we also have to multiply by the derivative of u with respect to x. And what this is basically just using the chain rule. It's just a matter of using the chain rule. So let me show you a quick example. Let's say we did this. We're taking the derivative from 3 to 6x. Actually, you know what? Yeah, that's fine. We'll do this. Of 2t. Just keep it simple again. So, antiderivative of 2t, we know, is t squared. But we're evaluating this from 3 to 6x. So, that means we have 6x squared minus 3 squared, or 9. So let's say we do the derivative of this the way it is. I know we can multiply this out, but just bear with me here. If we took the derivative of 6x squared the way it is, what would we have to use? Chain rule, right? We'd do the 2 out in front times 6x just at first, and then we have to multiply by the derivative of the inside, which would be 6. And then the derivative of this is just going to be 0. So for this, that's kind of what we get, and we can simplify it. Now let's look at that shortcut. What I said with the shortcut is we have to take this, plug it in for t, and then we have to multiply by the derivative of this. So we'd have 2 times 6x, right? We're plugging that in for t, but then we have to multiply by the derivative of 6x, which is 6, right? That's what we did in the long process here. So the shortcut is we're taking 6x, plugging it in there, but we also have to multiply by the derivative of whatever this is. If it's not just a plain old x, we have to multiply by its derivative. It's just chain rule, because we're taking the derivative of that whole thing. All right, so let's look at number 3 kind of the same way. Again, in the future, you won't have to show the work. Well, let's just do it the shortcut way first, and then we'll back it up with the work. If we do the shortcut, we're taking 4x, plugging it in for t, so we get cosine of 4x. But then we have to multiply by the derivative of 4x, which is 4. Right, so that's a shortcut. That's it. That's our answer. But just to kind of back it up and show, again, that's all you have to do. But just to show you how it's working again, just to make sure it kind of sinks in, we take the derivative of this, so we're going to do the antiderivative cosine is sine from 1 to 4x. That means we're taking the derivative of sine of 4x minus sine of 1. So derivative of sine of 4x, so derivative of sine is cosine, but then we have to multiply by the derivative of the 4x, which is 4. And derivative of sine of 1, that's a constant, so that's 0. So we can see we get the same thing. Shortcut saves us a lot of time. All right. With number 4, what do you notice about that one? Constant top and bottom. There aren't any variables. So if we were to evaluate this, we're not going to go ahead and do the definite integral, but if we were to like evaluate this, and these are both constants, we're going to get what as our answer? Well, before we do a derivative, we're just going to get some number, right? If we do this inside part, if we evaluate that definite integral, we're going to get some answer, a number. But if you take the derivative of a number, what do you get? 0. All right, so this integral is going to equal a constant. Right? If we evaluate that integral, we're going to get some number. We don't even need to figure out what that is, because then when we take the derivative of a constant, that's just going to be equal to 0. Right? Because there are no variables here.